Okay, so pointers and arrays we discussed in the yesterday's class. Okay, so today we'll discuss about pointers and structures. We have defined structure for storing employee details, for storing student details, for storing person details, for storing book details. Okay, so there we defined a structure variable and we accessed structure members by using dot operator. Okay, right? So those members now can also be accessed by using a pointer. How the structure members can be accessed by pointers? Okay, so that we will discuss today. Pointers and the structures. Okay, for example, consider we have defined an employee structure salary. Structure variable E and I initialize to these values. Okay, so E is an employee and whose name is ABC and age is 40 and salary is 1234.50. Okay, so when I define this structure variable E here, okay, so what happens? Immediately memory is allocated for this E. This entire block of memory is accessed with the name E, okay, and the first field is name field, then the second field is age field, and the third field is assume address of name is 1000, okay, then what is the address of age field? 1030, because name occupies 30 bytes, okay, so what are those 30 bytes? 1000, 1001, 1002, 1003 up to 1029. 1029, these 30 bytes will be allocated for this member name. Okay, so then 1030 onwards 4 bytes will be allocated for age. Okay, so then what is the name of the next field? That is salary, and what is its address? 1034. Okay, so 30, 31, 32, 33, these 4 bytes will be allocated for age, and 1034, that 4 bytes again 34, 35, 36, 37, these 4 bytes will be allocated for salary. Okay, so then in the name field ABC will be stored, in the age field 40 will be stored, and in the salary 1234.50 will be stored. Okay, and this entire block of memory is accessible by using a single name E. Okay, but E is not a single value, it is a mixture of values. Yes, okay, so how to access individual values? By using dot operator. By using dot operator, we can access. Okay, so in previous example, we accessed this value ABC by using E dot name and E dot age, E dot salary. That's how we accessed using the dot operator individual members of the structure. Okay, so today we'll talk about pointer. Okay, assume that we have declared a pointer to this structure. Okay, so struct employee star P. Now see here, P is preceded with star. That means P is a pointer. Pointer of which type? Struct employee type. That means it can store an address of a struct employee type variable. If you have a variable struct employee type variable, that variable address can be stored in a P. Or in other words, we can say that P can now point to a variable of type struct employee type. Okay, right? So we have already defined a struct employee type variable name E. Yes or no? Now you can make this pointer to point to that E. How it can be done? Now see here. So the address of the structure variable E now is assigned to P in this way. Now if you say P is equal to ampersand of E, here E is a structure variable. It is not an array, please remember. So that's why you must precede E with the ampersand symbol. Okay, so that indicates, that tells the compiler that address of E you please assign to pointer P. Okay, so when this is performed, what happens? Okay, so since P is pointing to a structure here, P is called structure pointer. We call it as structure pointer. Now see, this is the memory allocated for P, and we said that name field address is 1000. Yes or no? Okay. So that 1000 will be stored when you say address of E. Now see, in previous slide we have shown this is E. This entire blue shade block is named E and it has three addresses like 1000, 1030, 1034. Okay. So which address will be stored? Generally, whenever we say address of variable means the first byte address. The first byte address will be stored 1000. Okay. So that's why here P now contains 1000. Nothing but now we can say that P is pointing to first member of the structure. Precisely, it is pointing to name field of the structure. Okay, right? So once we have a link established between this structure pointer P and structure variable E, now you can access these structure members using this pointer without using the name E. Okay, now see how it can be accessed. Now structure members can be accessed using the arrow operator. Using the arrow operator. Okay, so this operator. So how it can be typed on the screen? Type minus sign, then followed by greater than symbol. Minus sign followed by greater than symbol, and that will be considered as an arrow operator by the C compiler. Okay, so this arrow operator now can be used to access structure members using structure pointer. Now see how it can be accessed now. See, this is the notation. P points to name. See here, this arrow we indicate or we read this notation as P points to name. That means now see here, this is what P now points to name. Okay, so indicates P points to name indicates the value present in the name field ABC. That indicates when you say P points to age, it is nothing but the value present in that memory location, which is 40. P points to salary, if you say it is 1234.50. Okay, so using the structure variable E, you can also access this ABC by using dot operator E dot name. If you say ABC, similarly, now there is a pointer pointing to this structure. So you can also access this ABC by using this pointer P points to name. How it can be accessed now? P points to name, P points to age, P points to salary. That is how we access structure members. Okay, right? Now you can just write a simple program demonstrating this structure pointer. In examination, question will be asked in the same way. Write a program to demonstrate a structure pointer. Okay, so that means you have to create a structure, define a variable, and create a pointer and store that variable structure variable address in that pointer. Then you access structure members using this structure pointer. Okay, so we'll write that program. Let me open the code blocks. Still someone is in lobby. There are no persons in lobby now. Yeah, 67 waiting in lobby. 74, sorry. Okay, 30 members present. Right. So we'll write a simple program showing structure pointer. Okay. So where is code blocks? Yeah, here it is. Now structure concept, pointer concept, both combined together. In yesterday's class, array concept and pointer concepts we combined together. Okay, using pointer now, everything can be accessed. A variable, an array, a structure. Okay, another pointer can also be accessed. Okay, so now see here. So I'll write a comment here, program demonstrating structure pointer. Structure pointer. So next step is include the header file stdio.h. Okay, so then you define your structure here. Okay, so structure something like employee, student, book, any structure you can define. Okay, so it is not that only employee structure should be defined. No, you can define any structure. So what details I want to store? I want to store employee name here. Name of size some 30 characters or 40 characters. You can define your own size. Then I want to store his age, employee age. Okay, so then I want to store his salary also. Okay, so then close the structure and end this definition with a semicolon. Okay, so once structure is defined, then write the main function, then begin the main. Now inside the main, what we do is first we will create a structure variable. Okay, so struct employee. Okay, so EIDA, and I directly initialize this E with some values. Okay, so E employee name something like Ramaya. I am defining. Okay, so employee age something like 45. Okay, so then is salary 1 2 3 4 5 dot okay, so 7 5 like this. If you initialize, then for E memory is allocated and these values will be stored. Okay, now we can access these values by using that means structure members. These are the structure members. These members can be accessed by using this structure variable E using dot operator. Okay, but I want to use a pointer here. So I define a pointer struct employee. Okay, so then I say star PTR employee star PTR. Okay, so that means PTR is a pointer now. PTR is a pointer now. Then diagrammatically, if you want this to be shown, now it will be like this. When you define struct employee E, okay, so then the memory for E is allocated this way. This is memory allocated for E. Okay. And so here 30 bytes will be allocated for a name field, then 4 bytes for a this. Okay, so this is the memory allocated for a E. Okay, so this entire block of memory is given the name E. Here, this is E here. Okay, so this is name field, this is age field, and this is salary. Okay, so you have given name as ABC. Okay, so age 45. Sorry, not ABC. This is something like what you initialize it to Ramaya. No? So here, program, you initialize this field, initialize name to Ramaya. Okay, so it will be stored as Ramaya 45 and age salary is 12345.75 like this. These values will be stored here. Okay, and when you say star PTR, okay, so then for PTR also memory is allocated like this. Now this is the memory allocated for pointer PTR. Now you have to make this pointer to point to this E here. Okay, so this link you have to create. How you can create link in the program? Now this is how you can create the link. Now both are separate here. Now I'm creating the link between pointer PTR and E. Okay, so just you say address of E store in a PTR. Okay, so then this link will be established here. So address of E is nothing but this first byte address that will be stored here. Assume that the byte address are stored here. Then now we can say that this PTR is pointing to the structure variable E. Okay, right? Now we can access these members by using this pointer. Okay, so what I do is I write two methods here. Okay, so otherwise you can just use pointer to access structure members. Okay, so just you say here employee details, put right, just type the heading employee details, just typing heading employee details. Now I'll show you how each member can be accessed using the pointer. Okay, so printf, then what is the first detail? Name. So employee name is equal to, so name can be percentage yes, then say new line, comma. Now see how name can be accessed by using the pointer. Okay, so now you can say p points to, how it can be arrow operator you have to use. Okay, so minus sign, then followed by greater than symbol, then that becomes arrow operator. Okay, so p points to name. Now you can say p points to name. Okay, so then it prints the value Ramaya. Okay, similarly age is equals to, age is equals to percentage d slash n, comma p points to age. You can say p points to age. Similarly printf, what is next one? Salary. Salary is equals to, so percentage f, then say new line, comma, how salary field can be accessed? Salary member, p points to salary, p points to salary. That's it. Okay, so then finally say return 0, close the main. That's it. Okay, so save the program. I'm saving the program here. So what is this structure pointer? No, say struct underscore pointer, structure pointer. Okay, so my program name is structure pointer. Now you can see colors appearing in the program. Now this is what I did. I defined an employee structure. Okay, so then I created a structure variable here. Then I created a structure pointer here. Now I am making this pointer to point to this structure variable. Now I am accessing members of a structure by using this pointer, structure pointer. P points to name, P points to age, and P points to salary. Then it prints name, age, salary of this employee. Okay, so now build the program. Right, so yeah, there is an error. What is that error? We will see. You should understand errors also. Okay, so build failed, one error. What is that error? Each undeclared identifier is replaced only for each function in the pair. Okay, so what is this undefined function here? There is some mistake in the program. What is that? CP undeclared. Oh, I have given the pointer name as PTR here, but I am using P here. Okay, so that's why it is saying that P is undeclared. So I am using this P which is not declared. So what is our pointer name? PTR, no? So just you say PTR points to name, PTR points to age, and PTR points to salary. Okay, so hope you are getting what type of errors will occur if you don't declare a variable. Okay, so intentionally sometimes I am writing these things so that you can understand why this error and what is the problem here. Okay, so immediately you have to check here whether the pointer P declared or not declared. What is its name? PTR. So I have to replace P by PTR, PTR, PTR you have to use. Okay, so again you build the program, save and build the program. Now there are no errors, no red mark here. That means no errors here. Okay, so now I run the program. Now you can see employee details. Name is equal to Ramaya, age is equal to 45, salary is equal to 1234.75. So using pointer, I accessed the structure members. Okay, so by using which operator? Arrow operator. When you want to access structure members using a structure pointer, you have to use arrow operator here. You can also access these employee details using dot operator. Okay, see here the same details now I can print using dot operator. Already we discussed it, but just for clarity I am showing again here. Okay, so employee details here, just you say using pointer. Using pointer I am printing employee details, and this employee details without using pointer. Okay, or using dot operator you can say, using dot operator. Okay, so how now these employee details can be accessed by using dot operator? So dot operator left hand side you should have a structure variable name, then dot structure member name, e dot name you have to say. Okay, so then you have to say e dot age, then here you should say e dot salary. Okay, so try to understand the difference. If arrow operator left hand side, there should be a structure pointer, right hand side members, structure members, and for dot operator left hand side structure variable. This e is a structure variable, ptr is a structure pointer. Okay, so understand the difference here. Now if I build the program again, save and build, now there are no errors. Okay, so let us see whether same details will be printed or not. Now see, 2 times printed. Employee details using pointer, Ramaya 45. Employee details using dot operator, same. Okay, so same memory location. Now using dot operator I am accessing, and the same details will be printed here. Okay, so if you understand the concepts, you can use any operator to access structure members. Okay, right. Yeah, what happened? Right, so structure pointer, arrow operator we can use to access members. Then there is another component called as a self-referential structure. Okay, self-referential structure, structure which is referring to itself, that is called self-referential structures. Just see here, self-referential structures are those structures that have one or more pointers which point to the same type of structure as their member. Okay, so that means inside the structure you will have a pointer which is pointing to the same type as that. Again, that is called self-referential structure. Okay, so in other words, structures pointing to the same type of structures are called self-referential structures, or self-referential in nature we call it as. Now see here, example, if I see, for example, I define a structure called as node. I define a structure called as a node containing 2 members. Okay, so I'm giving this structure name as a node containing 2 members. What is the first member? Data, which is of integer type, and what is the second member? A pointer whose name is next. And what is the data type of this pointer? Struct node. Struct node is nothing but name of this structure. Okay, so nothing but this structure can point to itself. Can point to itself. Same struct node type, a pointer you defined inside the struct node only. Okay, so this type of structure is called a self-referential structure. Okay, so in the above declaration, next is the pointer to the structure of type node type. Okay, so this is data type of this next pointer. It is pointing to a node. Diagrammatically, if I want to show this node, it will be like this. Generally, in second year, first semester, you will be having data structures subject. In that, you will be discussing about these nodes. Linked list concept is there. Okay, so there you will use this node structure, self-referential structure. Okay, now see here, each node, now this one diagram, this is called one node containing data and next field. Two fields are there. That means two boxes here. First box indicates data member. Second box indicates next pointer, which is a pointer to the next node again. Okay, so for example, first node contains data as A. Okay, so then second node contains data as B, third node contains C, next node contains D, next node contains E, like this. So here, this is nothing but ABCD is list. Okay, it is a list of alphabets, and these lists are stored inside the name, inside the node, and they are linked together. That's why this kind of representation is called linked list representation. Just remember, don't go in deeper into this. Okay, so generally 2 marks, 4 marks question will be asked on this. What is self-referential structure? Give an example. Just if you draw this diagram and if you show this employee structure or node structure here, that is enough. Okay, this is called a self-referential structure, and it is used in a linked list concepts in a data structures. Okay. Thirty-six members present. Okay, right. Today is 5th, no? And you are CSM students, no? So next, tomorrow, tomorrow I think you don't have a class, no? Okay, so file handling in C, I discussed this on Saturday. Okay, because for both ECA and CSM students together, I repeat. Otherwise, I need to repeat separately for both of you. Okay, so you might have stored your programs in files. Okay, like prime.c, that is one file. Okay, so like max.c, that is another file. Add.c, that is another file. So like this, you have created files, and each file represents one program. Okay, so what is file? We will see in the next class. And the same concepts which we use in our daily life. See, all our certificates we keep in one file or not? Yes or not? Okay, so that is hard copy of file. Now, the same soft copy of a file we'll create in the program. In system, we create a file where we store all the related data. That means in one file, we store all our certificates. Okay, so certificates related to me, one person. Okay, so that means they are related to each other. That's why we store in that, and we call it as a file. Similarly, in system also, you can create a file where you can store related data. Okay, so and where it is stored? It is stored on the hard disk. Okay, so these concepts I will elaborate in the next class, and how those files can be created. You might have created, but through C program you can also create a file. How it can be done, I'll demonstrate in the next class.